Hey, everybody. Happy Thursday, and welcome to our live stream on learning the Simulink basics on the MATLAB YouTube channel. This is Ed Marquez here. I work at MathWorks, and I focus on Simulink and model-based design applications. And today, my buddy and colleague Connell is joining us. Hey,
Hey Ed,
Connell.
how you doing? Hey Ed, how you doing today? My name's Connell, everyone. I've done a couple of these live streams before. Again, I work on the student competition team here. I help a lot of our student teams work on autonomous systems in aerospace. So we're excited to talk to you about Simulink today. Ed, this is your first live stream, right?
Yep, that's right.
Welcome to the live stream team, I guess.
Nice. Yep. So let's learn some Simulink basics today.
Yeah.
Let's go through the fundamentals. And whether you have heard of Simulink and never used it, we're happy to have you here. Also, if you've used Simulink but you want to get more familiar with it, we're happy to have you here. So let's get started. And at a high level, we want to answer 3 questions. What's Simulink? You're probably wondering that. So we'll go through that. You probably want to know, what can you do with it? What can you do with Simulink? And for that, you're going to see us do examples for modeling and simulation, and also for working with hardware in Simulink. And the third and last question.
I've got a little Arduino here that we can play with a little later. So
very nice.
Excited to see what happens.
Look forward to that. And the third question we want to answer is, how do you get started? Where do you learn more, and how do you get your hands dirty with Simulink? So to answer that first question of what's Simulink, I want to take us to mathworks.com, right? So here you see a nice banner for using MATLAB with AI, or for AI. Hopefully you're familiar with MATLAB. And today let's focus on Simulink here. So this is the homepage for Simulink. And at a high level, Simulink is a low-code environment for modeling, simulating, and analyzing dynamic systems. That's what it is.
So Ed, I just want to stop you right there because I know we're gonna have a lot of new people to Simulink on this stream. Can you answer this question for me? Does Simulink and MATLAB work together? Are they independent? Are they 2 separate products? Can you give me a little bit of a lowdown on that before we jump into what Simulink does and stuff like that?
Yeah, we get that question a lot. Yeah.
Can you actually run Simulink without having MATLAB? I guess that's a question I get asked a whole lot.
MATLAB and Simulink work together, right? So
Gotcha.
you do need MATLAB for working in Simulink. And that's the key point there, that they work together, and in a way that makes Simulink even more powerful because you have access to a lot of the functionality that MATLAB gives you. All right, so we saw what Simulink is, and you can use it for modeling multi-domain systems. What that means is that you can include multiple effects or domains of your system in one environment. So let's imagine that you're designing a wind turbine, right? You have to take into account aerodynamics, mechanical components, and electrical components. So you can include all of that in one environment. And as you model or design a system like that one, here are some of the benefits that you get with Simulink, right? You can model and simulate, so you can try situations that might be too time-consuming or risky to consider with a prototype, right?
Yep.
Simulation is also cheap, and it's fast to run compared to working with a hardware prototype. So you can test early and often, and when you do that, you can find issues earlier in your design process.
And I can see how that's useful, because I mean, if you're building something as big as the A380 or a huge jumbo jet, you can't build like 100 prototypes and test them and crash them. That's just not economically feasible. You don't have the time to do that. So
Right.
I can see how testing early and often is super important when you're building big systems.
Exactly, and that's not all. Once you have all these models, you've tested them, probably you need to end up running on hardware. And so a nice thing is that you can automatically generate code from these system models that you already built. Okay, so, and here I have again the point that MATLAB and Simulink work together, right? So that's one of the things that makes Simulink so flexible and so powerful. And so with this integration with MATLAB, you can do things like extend your analysis. Simulink gives you a lot of tools for analysis, but you can extend that with MATLAB. You can also automate things like running simulations and trying different parameters for your models. And you can even run your MATLAB code in your Simulink models, which is pretty cool. Okay, so again, now you know what it is. Let's jump into Simulink now. And the way I want to do that is by showing you Simulink on the web browser, right? This is pretty cool because we just introduced this, Simulink Online. And so if we just do a quick search for Simulink Online, that's the page you want to go to. And if you want to use all the add-ons for specialized tasks, the desktop version is great for that. But if you want to access Simulink from anywhere without downloads or installations, you can always try it from your web browser. Okay, so once you come here, let's just start using Simulink Online. And so you see this is loading MATLAB Online, and it's going to show me the Simulink start page in just 1 second. And so in case you missed it, I want to show you how to get to the Simulink start page. You can get to the Simulink start page by typing Simulink here in the MATLAB command window, or I can just click here on this button in the MATLAB tool strip. And the nice thing with the start page is that you have templates that serve you as a starting point, maybe if you want to design things like digital filters, feedback controllers, fixed step systems. In this case, today we're going to build a blank model step by step. So we'll walk you through that. And another cool thing about the start page is examples. And this is one of our favorite ways for people to get started. Just grab an example, run it, change some things, break it, and make some mistakes and learn along the way.
Yeah, I couldn't agree more. I think the one thing that I recommend to anyone that asks me how to get started with MATLAB or Simulink is just open up an example. You can click around. It's almost fun to open up an example, try to break it, and then try to fix it again. Because I feel like that's the best way to learn. You learn by doing things. So I'm all for starting from examples. So Ed, are we going to take a look at an example today, or are you going to build up a model for us?
We're going to do both. We're going to do both. Let's start by building
a
model step by step, and then let's look at an example that comes included with Simulink. And then another way you can get started with these on-ramps that are accessible from the start page, but let's get to that later in the session. Now let's just start building our model here. So it's creating the blank model. And here I have the Simulink canvas, right? So this is the Simulink interface. This blank area is the canvas. That's where we're going to build our model. And with Simulink, you have a tool strip very similar to MATLAB, right? So this tool strip is great because it shows you a lot of the capabilities in Simulink, and those capabilities are grouped and organized by workflow, right? So you have capabilities and options for simulating, debugging your model, for modeling and configuring the model, many things for doing the format. So you can, for example, set the background of your model and things like that.
Ooh, MATLAB dark mode.
Yeah, right. So I just did a Control-Z there. And then the last thing is apps. And these apps are great because these are user interfaces that make it really convenient to complete tasks or workflows, say things like controls task or workflows like automatically generating code from your models, and some other verification and validation workflows too.
Ed, so I'm just going to stop you right there because we got a couple of questions in the chat. The first thing is Simulink Online free to use? And is it free for students, I guess? So a couple of questions on that.
That's a great question. So you will need a license for Simulink Online, but the good news is that it's available for most of the student licenses. So if you're a student, you're most likely going to have access to that. It's also available for home use and the standard individual license.
Yeah, it's essentially, I believe what you need is a MATLAB Online license, which would allow you to use that interface. A MATLAB Online and a Simulink Online license.
All right. So let's build the model. Okay.
Yeah, let's go for it. I'm excited to see what happens.
All right. So I want to insert an image here just to show you a picture of where we're trying to go, what we're trying to build. So you saw there in the left tools, I grabbed image, and here you see my MATLAB drive. So this is all on the cloud, and I already have this picture of a dynamic system, which is something we talked about when we defined Simulink. Okay, so the system we're going to build today, step by step, is a spring or a mass spring damper system. Okay, you see the picture there, and let's look at the equations that represent that kind of dynamic system. So here I have the equation that represents the summation of the forces. In this case, let's keep it simple. Let's not have an external force. And I just substituted in the second line these formal terms like x double dot and x dot to things that I'm more comfortable with, so acceleration and velocity. And then in the third line, I just rearranged the equation. So that's the equation that we're going to implement in Simulink to model our system. Okay.
So it's essentially when you talk about a simulation, you're essentially solving that differential equation, right? Which is it may sound fancy and it may sound like it's this black magic kind of thing that's happening in the back, but essentially what you're doing is you're just solving a differential equation, right? Yeah. And Simulink's got these robust solvers that can help you numerically solve those differential equations. So I guess let's code up our differential equation.
Let's do it. And so the way to start inserting blocks and elements into our model is from the Simulink library browser. So you see there, I clicked on the button, and that's going to bring up all the libraries and blocks that are available to me to build my models. So here you see I have libraries for Simulink, and we're going to stay there today, but you see there are also things for more specialized tasks, right? Like aerospace systems, AUTOSAR systems, and much more. So if we look at Simulink, we're going to stay with the commonly used blocks today, right? We're going to keep it basic and fundamental. And here you see things like constants, gains, integrators, math operations that can help us build these kinds of equations. So the first block I want to grab is an integrator. That's going to be, the fundamental building block of the mass spring damper system. So you see I dragged and dropped it, and we can close the library browser. And so at the input side here, okay, and you also get some suggestions if you're new and you start using Simulink. So at the input side here, let's start with acceleration. And you see that when I integrate acceleration, we're going to get
velocity, right?
Velocity, exactly. And so now I could just copy, paste this block, and integrate velocity again. And what's going to be at the output side of that is my displacement.
Okay.
So let's call that x. And now we need to keep basically building this equation. So now what I'm going to do is I want to multiply this x times k. And so I could go back to the library browser, but if I already know the blocks or the names of the blocks that I'm going to work with, I can just click on the canvas and start typing the name of those blocks. And this will come to you as you use Simulink more and more, right? So here, let's grab a gain block. I can set it to be k. When you see that it became red, so Simulink is giving me a warning that, hey, this k parameter is not defined yet. I don't know what the value is, but we'll get to that point when we define all the parameters we need to simulate the model. Okay, so now I can rotate this block. If I go here to the format options of the tool strip, I can rotate it or just flip it. Okay, so let's do that. And let's connect k and x. Can move all of our stuff closer here. And Connell, help us out here. What is the output of this block here?
K times x.
Exactly.
There we go.
All right, and we're going to do the same for the V signal. So another way that I can insert blocks is if I double click on a connection that is not complete yet, Simulink will give me suggestions on what are the blocks that are most likely that I'll connect there, and only the blocks that are compatible. So it's doing some of the filtering for me. There you see a gain again, and I can change the value here in the icon, or I can just double click, open the block dialog, and see a whole lot more properties for that. In this case,
and this is where you can control things like data types and the size of the signal and stuff like that, sample times, etc. Oh, we should talk about sample times at some point, because I feel like that's an essential part of Simulink. So
yeah, and we're going to talk about that after we simulate the model. So here now we have basically the building blocks, or the right side of the equation, right? So now we need to add a math operation. Let's go with the add. And what we need to do here is we need to change these signs to be negative or minus and minus, right? So, okay. And what we get at the output of this here is going to be now mass times acceleration, right? And so we're really close to finishing the modeling the equation of the system. So now what we want to insert here is, again, a gain, right? Because what we're going to do with this gain is we're going to define it to be 1 over m. And you see that the parameter value there is kind of large, so it doesn't fit. But Simulink gives me the option to automatically resize the block so that I can show the value. So that's pretty nice. All right, so now we basically implemented the equation. And there's one more thing that we need to do. You see this XO, or this initial condition of 1 meter? Well, we can implement that here in this integrator. So you see the initial condition for it. Let's set it to x0. And it should be a red highlight because, again, we haven't defined many of those values.
Defined those variables yet. Yep.
All right, Connell, how do we visualize this data that we're going to get out of the system?
Oh, this is my favorite part. So you can do something. You can use the Simulink Data Inspector, or you can use things called scopes. So if you click on a particular signal, you have the ability to log it as Ed's doing in the on the screen, or you can actually add it into a scope. Logging it means that it's going to open up in the Simulink Data Inspector view, which we can show to you in a little bit. But Ed's essentially gone and added a quick little scope in there, which we can visualize our position or our X term over time. So
good stuff. Exactly. So yep, we did both. We're logging it and we're going to visualize it with a scope. And before I go and define my parameters, I want to save the model, right? So let's do that, and let's call this mass spring damper underscore model. Pretty creative there.
Very original name.
Yeah. All right, and that's going to be saved in our working directory, which in this case is my MATLAB drive. So there you see my model. And now we can start defining some of those values. And I could do it here in the MATLAB command line, or I could just use a script to do that. So let's use a live script. And actually, let's go ahead and save that live script as well. So mass spring damper underscore script. And let's start defining our parameters. So here, B was equal to 10. So that's the damping coefficient. Mm-hmm. Our K was equal to 400, and that's the spring constant.
Spring constant, yep.
The X0, or the initial condition, we said 1 meter.
1 meter.
And then we didn't have a value for M, which was the mass. And that was actually on purpose, right? Because what we want to do is we want to look at the response of the system as we change the value of the mass, right? Mm-hmm. And we're going to do that with MATLAB. So let's start with a value of 3 for the mass. And if I run this section of the script here, you see that my values are populated in the MATLAB workspace. And this is a global data repository where Simulink models are going to be able to see the data that I have here in the base workspace. All right, so if we go back now to the model with the parameters defined, I can run this. So there it compiles, and it'll run for 10 seconds, but that's 10 seconds of simulation time, not like real time. Yeah. You see that it completed already, so it did it pretty fast. And if I look here at the scope now, there is the response of the system, right? We're looking at the displacement.
Yeah, which is sort of expected. You know, you start at 1, it'll oscillate a little bit, and then the damper sort of comes in and damps those oscillations out until it's back at rest.
Yeah. Now I want to take this time here to talk about the sample times, right? Because you see that right now the signal is a little choppy; it's not very smooth, and that has to do with the solver, right? So if we go back and take a look at the solver settings here in this model settings button, I don't want to get too deep into the details of solvers.
Yeah, because we can do a whole live stream on that. Right? Yeah, on solvers, right?
Exactly. So, you know, I just want to let you know that there are options for running variable step, fixed step, if you want to run into or run on hardware.
On hardware. Yep.
Simulink is automatically selecting the solver for us. But what I want to change here is the maximum step size. So, if I were to type 1, this would be 1 second. And that means that every second, Simulink would be solving the system and updating the results, right? So in this case, I want to go with 10 milliseconds. So if we make that 10 milliseconds, let's apply it, hit OK. And here we can sort of see a comparison if I bring up the scope again. Here it is. And so I can run my simulation from the model or from the scope here. And now you will see that when it compiles and runs pretty quickly, you see the response looks a little better, right? It's smoother. So I want to show you also the data in the data inspector, since we talked about it. And the cool thing about data inspector is that it logs the different simulations, right? So here's the data from the latest simulation, but then you can compare with previous simulations and overlay the data. So you see when it was choppy and when we made the sample time really small, you see how smooth it got, and you can see the comparison there. So that's
it's actually interesting because now we can go in and change that mass value and sort of compare the different simulations together and see what our displacement is. Right? Did I take the words right out of your mouth?
Yeah.
There we go.
Now we're gonna do that with MATLAB because I want to take us back to that point that Simulink works with MATLAB, right? So one of the things that we could do is write a little script where we simulate our model multiple times by changing the value of the mass. So let's do that right now. And the first thing I want to do is create a model variable that is going to grab my current system. And if you're not familiar with this GCS, it just grabs whatever model I'm working with.
Yep.
And I love this stuff about MATLAB, the command window, because I can quickly try code, right? And so I know if what I'm writing is working or not. So that's a quick tip there. Then we want to try different mass values. So here, we're going to have a vector from 1 kilogram in increments of 2 until 11 kilograms.
Okay.
All right. Then we're going to put this stuff in a for loop, and our counter is going to be from 1 to the number of elements
in mass values.
In mass values.
There we go.
Right. And I also love the live script because it sort of autocompletes things for me.
It's like cheating, right?
Yeah, it's almost like it. It's so easy that it feels like cheating. All right, so now we got the loop, and the first thing we want to do in the loop is change the mass value. So M is going to change to be mass values of I. And then after I've changed the mass value, I want to sim my model variable. But I do want to get or capture the outputs of that sim in this variable called results.
So this sim command is going to execute that model that's working, right? Gotcha.
Yeah, exactly.
Okay.
So now, since we're capturing the outputs and results, we're going to plot results dot, I believe it logs out. So that's whatever we're logging with the data inspector, or we get some output here. And then we're going to get the signal that we're logging, which is X, and we're going to get the values of X. We'll do a hold on to make sure we overlay the plots on top of each other.
Yep.
And then I'm going to create another variable called legend labels of I, and this is going to be a cell array that has basically all the strings that show me the mass value that I'm currently running. So one cool thing with MATLAB is that I can actually add strings. So there you see the mass value is equal to num to string of M. Right, so that'll display the mass value in the legend. And I think, yep, we're good there. And then I also want to display the status of my simulation. So let's say simulation to string. So simulation 1 or simulation 2, so that'll be I,
yep,
is complete. Right? And then outside of the for loop, I want to provide a legend label to the plot that I'm creating that uses the whatever I had in this cell array. So legend labels. Oops.
Yeah, I might want to correct that spelling. There we go.
Thank you, Live Editor. All right, so this, cross fingers, this should work. But before I run this, I want to go back to our model and show you a quick tip. Since we're going to run this multiple times in iterations, let's use this fast restart. And so what that's going to do is the model is going to compile one time, and then the simulation is going to be ready to start, for the next iteration. So it'll just speed things up a little bit.
Okay.
All right. So moment of truth. There it is.
Oh.
So it's updating the status. Simulation 1 is complete. There's 2, 3, 4, 5, 6, and there is our plot with the results. So I can open that in its own figure. And you see how we automated with MATLAB all these simulations and the analysis of the results. So we extended the analysis capabilities that we get with Simulink. So here you see each one of the lines for each one of the mass values that we're trying in this mass spring damper system.
This is awesome. I mean, it's great because like what we saw is we essentially we have a script with a bunch of code, but really what we're calling is that one sim command. Everything else is really just plotting it out. But you can see in this way, if you have multiple parameters in your model that you want to sort of test test different parameters, test different configurations. You can sort of step through all of these, in different permutations and combinations, and do all that for MATLAB. So it's great. You have all the results. You can analyze them after the fact, and yeah, I just think let's stop for some questions real quick.
Sure. And I also want to add to that point that you were saying that it makes it really scalable, right? Because we just automated running 6 simulations, but at the same time, I could run 100 or 1,000 changing the values.
Yep.
And I could even run these in parallel, but that's a topic for a different day. So if you're interested in that kind of topic, let us know in the comments below.
Okay, awesome. So we've got a couple of questions. It talks about, so the first one is, can you model nuclear particles moving in a metric of general relativity with Simulink in 3D? Ooh, that's a bit of a loaded question. Essentially, what I want to say is, with Simulink, if you have the equation, if you have the differential equation for a system, you can put that into Simulink and model it. So technically, yes, without sort of going into specifics, yes, you can. As long as you have a differential equation for it, you should be able to model it. I'm not sure if we have. It may be a good opportunity for you to look up File Exchange to see if someone's already actually built that model before. But definitely, if you have the differential equation, you can model it in Simulink.
Exactly. That's a great answer. That's a way to put it. Good way to put it.
There's a second question about, does M need initialization before the for loop?
Well, it needs initialization for the model to run even one time.
Yeah.
Basically, the answer,
maybe
the answer is no, right?
Yeah. Technically, could be no, but
yeah, because we could initialize it here before we run. The important thing is that you have an M value before you simulate the model.
Correct. All right. There was another interesting question on the sort of working of Simulink Online. So someone's asking us, hey, how does MATLAB Online execute code? Where is all this? Where is this code running?
It's running on the cloud.
Yeah, MATLAB Online runs on MATLAB on MathWorks servers. Essentially, you're just spawning up a cloud instance of MATLAB, and everything's happening on the cloud. So it's pretty awesome. You can use it in a browser. You don't really need to download the whole product. It's really handy. I've seen people use this on tablets, which like blows my mind. It's crazy.
Yeah, exactly. MATLAB is going mobile too. There's a version of MATLAB mobile, which is pretty awesome. And since it's all running on the cloud, when you save files, it's actually here on your MATLAB drive, so you can access these files from anywhere, which makes it really powerful and convenient.
Yeah, awesome. So Ed, is there anything more that we need to cover here before we move on to hardware?
Yeah, good question. Let's quickly, so we saw how to build that model step by step, how it integrates with MATLAB, and let's quickly take a look at an example that actually comes with Simulink. So if we look at this example here, and we like to call these shipping examples, but you get them, for free included in the product.
The product, yep.
So what we're going to see with this example is what we just built step by step. But what I want to show you is a couple of different options that you have to build these kinds of systems. Okay. So here we get some annotations with these examples and resources to get started. We're not going to need that for now. And then I'm going to move this up here. So again, what you see here is basically the model that we just built step by step. And we did that by deriving the system equations and implementing those equations. But what if you don't know the equations of the system that you're trying to model, right? Or what if those equations are really complex? Or maybe you just don't have time to derive the equations for your system. So Simscape or Simulink can still help you with that. And the answer to that is with physical modeling. And that's the kind of model that you see here to the right. And Simscape is basically the platform for doing physical modeling within Simulink. And one of the nice things is that this model looks a lot like a schematic, right? That you see the spring, the mass, and the damper. But this is a schematic that simulates and gives me results. So it's really valuable. And another thing that I really like is these physical models are really easy to extend. So, if I wanted to model a double mass spring damper system, I could just copy paste, connect it, and then Simulink is doing all the math and the equations under the hood for me. right? So that's what physical modeling means.
So it's essentially you've sort of got two avenues to go down. One is when you know the differential equation, you know all the parameters involved with it. You sort of use Simulink and solve that up. Or if you're more inclined where you don't really know the math, you're not 100% sure, you can actually sort of string up simscape blocks, so physical connections and build your model out that way. Again, different fidelity levels depending on what your application is. You need to pick and choose what works best for you. But as you can see, both of them perform in the same way, given the same parameters. Yeah, it's a pretty quick and easy way to get started.
Yep. And then the other thing I want to mention is, today we covered a really basic example, right? And you can extrapolate this kind of system to be the suspension of a car, maybe the landing gear of an airplane, the airplane itself, or a wind turbine, maybe a robotic arm. And so you have an idea of what Simulink is used for. I want to show you these models for every project section that we have. And you can use Simulink. You see here a model for wireless communications. So you can use it for RF design and antenna systems. You can use it for power electronic control design, for developing control systems and control algorithms, Simulink for signal processing, robotics with physical modeling, for ADAS and automated driving, and even things like digital twins, right? Where you have a physical asset operating on the field and then you're getting real-time data from that asset and feeding it to your model or your digital twin, and you can use that for things like predictive maintenance. So definitely a lot of cool things you can do with Simulink. All right, so now once you have something like this, you probably want to develop a controller for it to control its response, and maybe you'll end up working with hardware. And I think that's exactly what Connell is going to show us today, right?
Yeah, let's go for it. So let's sort of work through some technical things as we get my screen shared. But essentially, so Simulink sort of works in a couple of different ways. One is we looked at the modeling and simulation part of it, but Simulink can also help you program hardware. So we've got a whole host of different hardware that we can program. I highly recommend that you go and take a look at mathworks.com/hardware to see all the supported hardware that we have. But for today's example, as you can see on my screen, we're going to be working with an Arduino. Arduino is something that everyone's really familiar with. Essentially, what happens is Simulink is able to program hardware through something called a support package, okay, or a hardware support package. And essentially, what a hardware support package is if I go into my my library browser, you can from the MATLAB interface. Let me just clear the screen real quick. If you go into the add-ons tab up here, you can choose get add-ons, and you can download such kinds of support packages. So you've got a Simulink support package for Arduino hardware. I already have it installed, but you can do it. There's also support packages for a bunch of other different kinds of hardware. But once you download that library, essentially what you get is, as you can see here, you get a library of blocks that are specific for that particular hardware. So with the Arduino, we've got Arduino blocks for the Arduino motor carrier. We've also got some, so as you can see, encoders, etc. We've also got some, I don't know where that went. Just give me a second. There we go. We also got some common blocks, Ethernet shields, etc. Let's take a look at the common blocks because that's what we're using. So for today's example, I've got a little servo motor here, as you can see, and a little Arduino Uno. And we're essentially going to figure out a way to command the servo motor. So the motor that I have is a continuous rotation motor, which is kind of like, although it's called a servo motor, continuous rotation servo motor is kind of like a speed controlled DC motor, I guess. But essentially, what you can do is you can grab these blocks that'll help you program the hardware. So with the Arduino, I want to give it a signal to the control signal port on the servo motor. So I've gone and grabbed this this continuous servo block, which is from here. I already have it in my model. So let's open this up real quick. Now, essentially, what's happening here is I'm gonna add it I'm going to show you something called external mode. External mode is essentially a way to deploy code onto a hardware, but still sort of interact with it as it's running. So again, there are two ways of programming hardware. You can either deploy the code and it runs standalone. So MATLAB's out of the loop, Simulink out of the loop. Your hardware runs on its own, or you can run it in what's called external mode, or now called monitor and tune, which is the code's deployed onto the hardware. It's still running on the hardware, but you can actually control it from Simulink. So what I'm going to do real quick is I'm going to add a constant block in here, and just connect this up. So essentially, what I'm doing is I'm giving it a PWM signal. I'm writing a PWM signal to pin 4 on my Arduino, as you can see. If you click this guy, you can choose a pin number here. It's pretty nice.
Yeah,
and then
Connell, I want to say that's one of the cool things about these, support packages, right? That you don't have to write any low-level device drivers. So you just grab these blocks and you just talk to the hardware. So it's pretty cool.
Exactly. It's because more often than not, we essentially, when we build this building, we don't want you to learn a new language. We don't want you to to sort of reinvent the wheel, to do something that it's probably not in your realm of expertise, right? You probably are familiar with Simulink as a tool, but if you want to program hardware, you probably have to use another programming environment. We want to get rid of that for you, so we give you these hardware support packages.
Yeah, that speaks to my experience. I'm a mechanical engineer by training, and I'm not a coder, right? So if I had to drive or write device drivers, I'll be going crazy.
Exactly. Exactly. So I've added a knob in here. I can connect this knob to this constant block. So I know that my motor is expecting a value between -90 and +90. So essentially, one particular it'll control which direction the motor is working in. Okay, so I've built this up. Let me just go in and connect this to the constant block. So I select the constant block, and it's asking me to connect it. Apply, and we should be good to go. So if you notice this real quick, as I move this around, it'll change that value of the constant block that's being written to the Arduino port. All right, so let's start this off at 0. The minute you can go to the hardware tab up here to choose hardware settings. You can choose the different boards. I've got an Arduino Uno, so I'm going to choose that. But you've got a whole list of boards that you can. And here is that Get Hardware Support Package button where you can get more support packages. But what we're going to do is I'm going to click the Monitor and Tune button. So essentially, what's going to happen is if once you do this, if you can see the bottom left-hand side of your screen, it's sort of giving you instructions as to what's happening. So right now it's saying that it's building. Essentially, what it's going to do is it's going to convert this Simulink model into C code or whatever code your hardware requires, and compile it and go and dump it onto the hardware. So I've got my Arduino connected to my computer here. It's still building. It takes a few seconds to build.
All right. So maybe while that builds, we go through some of the questions that are coming in, and one of the question is, what are examples of other hardware that is supported? So just to mention a few.
Let me just pull up the page, mathworks.com/hardware.
So yeah, I'm sure we're gonna see a lot of them here on the page.
You can pretty much go through this entire list, and there are a bunch of different manufacturers. There are a bunch of different kinds, but like we support most ARM boards, most Arduino boards, a lot of National Instruments boards. Raspberry Pi is another one. I really like the Raspberry Pi support package because you could do things like computer vision and all that kind of fun stuff. We've also just got support for the NVIDIA Jetson. So if anyone's working with that, you can actually program NVIDIA Jetsons with deep learning models directly from Simulink. Maybe we do a live stream on that another time.
Yep.
All right. Okay, so it looks like the code's built. This is the code generation report, which sort of shows you the different files that are being added. But Arduino server, the Arduino server.c. This is the file that actually consists of the code that's deployed to the hardware. So I'm just going to exit out of this real quick and sort of show you my model. I'm going to hold the servo up here. But you'll see as I play around with this knob, the servo starts rotating, and you can see it rotating really cool. The clockwise direction because I'm giving it a positive value. And then if I flip it over, it's going to rotate in the other direction and then 0 means stop, so that's what it's going to do. This is a continuous rotation servo, so we're not actually giving it an angle. We're sort of giving it a speed value. So if I give it a small, it's going to rotate slower. And then if I go to -90, this is like the maximum speed that it can work at. But essentially what we wanted to show you was that, hey, without really, like, I don't know how to write C code. I built a model in Simulink, a language that I'm familiar with. And I'm able to program hardware pretty much by the click of a button, which is great. So that's as far as programming hardware is concerned. Please pop your questions in the chat, and we're happy to do another session on this if you want to sort of get more involved with programming hardware. I know this is just a little bit of a teaser, but we're always ready to do more.
Yeah, but one of the things I love about this, right, is that we could probably write some C code and try to do it, but it would take us, I don't know, 5 hours to figure this out. I'm really slow writing C code, but you saw we built this in a matter of minutes, and so that's really the benefit that you get when you use Simulink for hardware. Okay, so maybe we take a few questions. Can you integrate 3D models so you get to see the sims? And if so, what extensions of 3D files does it support? So you can include 3D models, and the answer to that again is physical modeling. So Simscape allows you to import geometries that you can then use with your Simulink models. And there are multiple file extensions and also file types that are supported. So you can import a whole assembly, or you could just use a block to import a single component. And off of memory here, I think some step files are supported from other software.
Yeah.
But there are multiple options that you can import into your simulations.
Yeah. So we have another. I guess this is more of a comment. It's sort of in the in the chat. But there's a person asking if you can do a full project with MATLAB and Simulink and deploy it. Yes, essentially that's what model-based design is, where you sort of stay in the same environment. You can again now. We've really only used Simulink blocks here, but you could just as well integrate MATLAB code in through a MATLAB function block. But yes, you don't really need to go out of the environment to program hardware or perform your entire project. So yes, that's possible.
Yeah, and this is a little bit of a deep topic here, but we like to refer to Simulink as a simulation integration platform, where, like you said, you can bring in existing MATLAB code that you already have and run it with your model, or maybe C++ code, or maybe even build your own custom functionality and plug it into your Simulink model. So definitely that is possible.
Yep.
There's a question on, could we do simulation of 2 different controllers like PID and fuzzy using for loop?
I guess you could. It's essentially MATLAB allows you to programmatically control Simulink models. So you can go down to the point where you're adding blocks in, removing blocks out. So yes, if you have a for loop, which sort of you can take a look at the documentation for this, but add in a particular block or subtract a particular block, that's definitely possible. I recommend taking a look at the documentation for that.
All right, Connell. So how about we jump into the third question for the day, which is, how do you get started?
Let's do it, man. Let's do it.
And how do you get your hands dirty with Simulink? So let's do that. All right. And I want to show you a few ways to get started, right? So let's go back to the Simulink start page. It's called the start page for a reason, right? A good point to begin. And probably one of the best ways are these on-ramps. So we have on-ramps for multiple products, and these are free interactive tutorials. They last from 2 to 3 hours, and you can learn the product by using it and solving problems and working on a project. And so we have some for MATLAB, Simulink, Stateflow, control design with Simulink, deep learning, and a lot more. And from Simulink Online, you see you can access the one for Simulink and the one for Stateflow. So let's give you a quick, let's take a quick look at the Simulink Onramp here. So here you see the multiple sections that it covers. So an overview, the overview again of the graphical environment, working with signals, building a basic algorithm, and then you get to work on some projects. And then you see the integration of MATLAB and Simulink. Then you cover dynamic systems and discrete time and continuous time systems and a lot more, a few other projects. So just to give you a quick taste, if we click on that running simulations piece, here we can take a look. If we change the size of these windows, and to the left, I get this panel. Here, let me resize really quickly to show this in a better way.
While he's resizing, there's a question asking about, is the on-ramp free? Yes, the Simulink on-ramp is free. You can just go. I think they've popped a link to the chat. They've popped a link to it in the chat. But you can go to that, and it is free.
Yep. And as I said, the cool thing is that you get to try the product, with step-by-step instructions. And so in this case, you're modeling the velocity of a falling object, so sort of similar to what we did, where you have a few integrators and gains. And the first task is to run the model. So you just have to make the connection. And when you click submit, then it evaluates your answer. So it'll compile and run and tell you, yep, you got it right, or maybe try again, and it'll give you feedback. So you're learning as you're trying the tool and getting immediate feedback there. And then you can move on through the multiple tasks there. So that's a great way to get started with Simulink Online and the Simulink Onramp. I also want to quickly talk about learning resources online. So if we go back to the homepage of Simulink, we have this section here for getting started, right? So there, again, you will see an invitation to the Simulink Onramp. But you also have a lot of video resources that we put together for you. So you have some getting started videos for controls, some getting started videos for signal processing. And then there's this detailed series that walks you step by step on how to build a model, and it actually gets deeper into the weeds compared to what we did today, which was just learning the basics.
Yeah. So there's a question in the chat on asking how does I think I lost it. Oh, there we go. How does Simulink contribute in designing control systems for vehicles? I feel like go through this video series; it'll give you a good idea. But essentially, what's happening there is, like we built that plant model of the mass spring damper, you'd have a plant model for your vehicle. It again, the fidelity level would depend on what type of a controller you're designing. But we've got some PID blocks that or blocks that implement different controllers like PID or MPC, and all of that fun stuff. And you can tune those controllers based on whatever plant model you have, and then follow that hardware support package code generation process to deploy the controller part of your model onto whatever embedded controller your vehicle's using. So in 30 seconds, that's how you'd use it for control systems for vehicles. But if you watch the series, I'm sure you get more information on that.
Yeah, and if you're talking about how Simulink is used for control or for control algorithms in production environments, for cars, then it's the whole process of model-based design where the model, is at the heart of the design process. And as Connell said, you probably have a plans, but you also have an algorithm that you test over and over and over until it's safe to run it in the vehicle, and you implement it in production hardware. And I feel it's pretty safe to say that many cars out there are running Simulink auto-generated code in their controllers. Yeah. All right, so I wanted to show you also some additional resources just from MATLAB Online. So you saw the videos, but then here's a big one, which is the help. And the help, you get documentation and examples. So if you click on documentation right from the product, here we can see, for example, if we go to Simulink, you see all the topics from getting started to really deep topics. And what I love about this is the examples are right here. We talked about examples as a good way to get started. And so there are examples that show you how to use certain features, or examples that show you how to go through a workflow or an application. Okay, so definitely try those out and make mistakes and learn from that. But this is one of the quickest ways to get started. And then the last way that I want to show you is the community. And again, you can access the community right from the product itself. So you see in these resources, if you just click on community, whoops, it will bring you to MATLAB Central. And so in MATLAB Central, so you can see, MATLAB Answer. So many of us will go there and just answer user questions. And the community is working together to answer some of these problems and questions. And something that Connell also mentioned, which is file exchange. So here you'll see code and entries that are shared by math workers, but also by users in the community, and you can use all these models. So these are pretty cool, and you can see some nice applications like aircraft design, vehicle design, working with hardware, and a lot more.
Essentially, one thing that I like to say is there are what are we, 2 million MATLAB users? Some crazy number like that. Everything that you're trying to do has been done before. Like very, very rarely do you come across an application where someone hasn't done it before or hasn't made like a video on it on YouTube or put it up onto File Exchange. So I always like to start writing code. I always go to File Exchange first and look if someone else has done something, and then sort of start from there, right?
Yeah, and you can find pretty cool entries here, like vehicle templates and all kinds of cool models like backhoe models and walking robots and things that you can just download and try for yourself.
Yep.
All right, so that's all I got. Do you want to go through maybe some questions?
Let's do some more questions. There's a question on can you do the Simulink Onramp if you haven't done the MATLAB Onramp?
Yes, you can.
I guess technically you could. For me, from a learning perspective, I'd do the MATLAB Onramp first, just because you'd get familiar with the interface and stuff like that. But there's no reason why you have to do the MATLAB Onramp first before doing the Simulink Onramp.
Yeah, exactly. There's no dependencies where you have to complete one first. But as Connell said, it just sometimes makes sense to get familiar with the fundamentals of the platform, which is MATLAB, and then move on from there. But yep, you can go in whatever order you want.
So we have a couple of questions on code generation. So I know a couple of people have asked about so onto the hardware. That being said, you can also generate. So if you remember that code gen report that we saw, you can edit that code. So if you don't want to, if you feel like you want to generate the code and maybe integrate it into another code base or something like that, that's possible as well. So it's not only getting deployed onto the hardware. You can access those individual code files and edit it and stuff like that later. So it's definitely possible to convert it into standalone C code, or I guess editable C code, C++ code, and then do whatever you want to do with it after. So that's definitely possible. There's one question on can we get the mathematical equations from the Simscape module? Ed, do you want to take that?
Yes. Many of those blocks you can actually see the source code, and that source code that is under the Simscape blocks is actually based on MATLAB. So the answer for most of those will be yes. Some components will be protected, and you won't be able to get those, but for most of them, yes. There's one on tips on troubleshooting and debugging when you get errors. Do you take that one already, Connell?
I don't think we did. Maybe,
all right,
maybe we can actually do a full live stream on debugging Simulink errors. I think that could be something that we could do next.
I love it. Yeah. Yep.
Yeah. I'm a Simulink user as well, and I sort of the Simulink errors are you need to use it a little bit to figure out what's going on. So maybe that's a good next live stream topic for us to talk about debugging Simulink models.
Yeah, and it'll depend on the kind of error that you get, right? So if you're working with a basic model, usually it's pretty easy to debug that. But as you get with more complex models, it might be good to go deeper into the details of debugging. Now, please let us know in the comments below what kind of topics you want to see in a future live stream, and we'll take a look at those.
Yeah. I'm trying to look and see if we've got any more.
Well, if not, people can always contact us, engage with our videos over emails or in the comments, and then we can get answers via that way. Or again, the community with MATLAB Answers. You'll probably get a response for
yeah.
for
There's one question that I'd like to take. So it talks about connecting VREP and Simulink. I think a good way to answer this is to talk about simulators in general. I believe there is a file exchange entry for VREP, if I'm not mistaken. But with other simulation environments like Gazebo or Unreal, we've actually got blocks within our product. So I believe the Unreal blocks come up in the UAV toolbox, the new UAV toolbox, and the automated driving toolbox. And Gazebo is another one that we ship. We ship sort of co-simulation blocks for as part of the robotic systems toolbox. But yes, you can essentially use those external simulators to either visualize or and we've got this new co-simulation feature now where you can use Simulink to control the sample time that's happening in the external simulator. So I recommend you go and take a look at the documentation for that, because there's a lot of good information on that.
All right, so I think we had a pretty fruitful discussion today. You saw the basics. Again, the goal was to answer the 3 questions of what's Simulink, what can you do with it, and how do you get started. And we want to thank you for your time and for joining us. This was great. So we'll see you next time.
Yeah. Hey, pleasure talking to you guys. We'll see you soon.
Take care.